Alright, so in this lab, we have a diethyl ether solution, and in this solution we have dissolved an acidic compound, a neutral compound, and a basic compound. And we're going to try to isolate these compounds from the diethyl ether solution through liquid-liquid extraction. So first of all, we're going to isolate our base. Alright, so first of all, we have our separatory funnel, and we pour the diethyl ether solution into the sep funnel. Next, we're going to add probably about 5 milliliters of hydrochloric acid solution into the sep funnel as well, and we're going to see how the layers separate. So the top layer will be the diethyl ether solution. The reason for that is because according to the CRC online, diethyl ether is less dense than water, so it'll form the top layer, and the HCl aqueous solution will form the bottom layer. So what we're going to do first is we're going to unclamp the sep funnel, going to make sure that the stopper is on, and then we're going to turn it upside down, and we're going to swish it around to make sure that we're mixing the diethyl ether and the HCl as best we can. And while we're doing that, we're going to first of all make sure that it's pointing away from people, and then we're going to open the stopcock and release the pressure every now and then. So once we do that, we swish it around a few times, make sure it's mixed well. We're going to close the stopcock, put it back on the clamp, and then we're going to watch these layers separate again. And once again, the diethyl ether will be on the top layer, and then the HCl solution layer will be on the bottom. So we're going to separate these layers by emptying out the hydrochloric acid layer into a designated flask. So we're going to do that until the interface just stays inside of the sep funnel. We don't want it to go through, we want it to stay inside the sep funnel. And the reason for that is because the rule is that we keep the interface in the same layer that we're going to be extracting from again. So in this case, the diethyl ether layer. So we do that, we separate it, we empty out the HCl solution into the designated flask, and then once we do that, we close the stopcock, keeping the interface in here, in the sep funnel, and then so after that we need to get a different flask, and that'll be the flask that holds the diethyl ether layer. So at that point, what we do is we open the stopper and we pour it into that flask. And then we need to take that same flask with the diethyl ether, we put it back into the sep funnel, and then we use a fresh batch of hydrochloric acid, again about 5 milliliters. We put it in, we do the same thing, we stir it, we will not stir it, sorry, we mix it, and we open it up, make sure that the pressure is being released, making sure that it's pointing away from people, and from ourselves, of course. And then we once again separate it, keeping the interface in here, and then we will have our separated HCl layer and the diethyl ether layer. So we are able to extract the base because chemically what's happening is that the nitrogen here has a lone pair, and the hydrochloric acid, like what it'll do is it's going to make H3O plus in the water, and it's going to pull the lone pair away from the nitrogen, and it's going to go to the hydrogen, and then it's going to break this bond here. So then it's going to form this compound here, and then water. And I'm sorry, it will actually make an H right here. I need to change that. So this is no longer a lone pair, but rather it'll grab that hydrogen there, and then we have here a conjugate acid, and then water. So next we're going to separate our acid. And again, this is the same thing that we were doing before. So we pour the acid into We pour the diethyl ether layer inside of here. We mix it up, we separate the layers. It's the exact same procedure, except that instead of using hydrochloric acid, we use sodium hydroxide. And again, it'll still form the bottom layer because it's more dense than the diethyl ether layer was. So we separate the layers here into the designated flasks. We mix them, we do the same procedure, and that's how we separate the acids. So what's happening with the acid chemically is that it gets separated and it gets pulled into the aqueous layer, just like the base did. The base got pulled into the aqueous layer because it had a charge on it. And sorry, I need to show that too on this previous one here. I'm sorry about that. There's a charge on this one too, on this conjugate acid, and that's why it'll be able to dissolve in water, and that's why it gets pulled into the aqueous layer. So the same thing with the acid. We have the sodium hydroxide, the hydroxide ion, which has a lone pair, and it'll break the bond between the hydrogen and the oxygen, and it'll create a charged, it'll be a carbon ion here, and then that will be our conjugate base. And this also gets pulled into the aqueous layer. So it'll make that, and it'll make water. Alright, so at that point, all we have left in the diethyl ether layer is the neutral compound. So what do we do now? We need to soak up the water. We can do that one way is by salting out, so what we call it. So we can put sodium chloride and water into here until we don't see any more of clumping, and then we put a little cotton swab in here. We put the Pasteur pipette into the cotton swab thing, and then we can separate the diethyl ether that way. And then we put it into a different flask, and then that flask will only contain the dry neutral compound and the diethyl ether. So then at that point, all we need to do is put it into a rotary evaporator, and the rotary evaporation will be a lot better than just simple distillation because it is done at a lower temperature and a reduced pressure, which makes it more efficient. And it's also faster because there'll be a lot more surface area that the solvent can evaporate from. And then from that point we have our solids. We just have our solid. And so then from that point we can obtain our solids from going into a Buchner funnel. We use the same apparatus that we used in the previous, like in lab 1, the Buchner funnel and suction filtration. And that way we can obtain our precipitates.